Hi, this is Andy from Home Septic. Just going to take you through choosing a sewage treatment plant, part 1, conditions. So here we're going to look at what conditions an engineer will look to gain an understanding of before recommending a tank to you when they come to visit for a quote. So looking at the overview, we like Graf and Harlequin tanks, mainly because of value, reliability and performance. Most large installation companies will look to force you down a certain tank selection route. This is because they have a financial benefit in doing so. For example, if you look at the top answer on Google for what is the best sewage treatment plant, it's written by a tank manufacturer, so it's obviously going to be biased. So what we want to do here is try and show you how you can undo that bias and make your own decision. Okay, so firstly, the considerations for the tanks. So the main bits that we'll be looking at when, or what an engineer should be looking at when they come to your property is water table, space, including access, soil type, drainage potential, where's the discharge going to go? Can you use gravity to discharge the treated effluent? So the water table and groundwater are quite self-explanatory. If your water table is higher than 3 metres below ground level, there's running sand or groundwater, it's going to make installation really difficult, potentially dangerous for an installer. Therefore, you need to understand, or the engineer, you need to understand if you have an issue with groundwater. If you do, it's not the end of the world. What we'd normally do in such a situation is look for a tank that is as shallow as possible. So, for example, Marsh do a shallow tank, which is only 1.6 metres deep, which requires a lot less digging than, say, a normal Graf tank, which is 2.8 metres deep. Secondly, you need to look at space. So, can you fit a tank in? Have you got access for the tank? Can you effectively, if you can't discharge to a water course, do you actually have space for a soak away? Do you have enough space to bring machines, etc. on to site? For example, if you can't get a digger on site, then everything's going to have to be hand dug and hand moved out of your garden or the area where you've chosen to have your tank, which increases the cost massively and also limit the type of tank we can have. I mean, for example, we had tanks where you've had to crane it over a house to get into the garden, and obviously you don't want to be doing that with a massive tank. Okay, so soil type. So different soil types have different types of absorption. Clay doesn't absorb water. Loose shingle does. Basically, this has an impact on how big the drainage field needs to be. If you're not discharging to a watercourse, it also impacts the excavation, how hard it's going to be to dig the holes, dig the trenches, and all of that sort of stuff. So that all needs to be taken into account. So really, you need to understand what type of soil you have. Maybe look to undertake a percolation test on your soil, which is basically dig a hole a metre by a metre, then dig a further hole at the bottom of about 300 millimetres and measure time, how long it takes water to dissipate from that secondary hole. There's instructions on our website how to do it, or just give us a shout and we can tell you how to do that. So where's the effluent going to discharge to? Is it going to go to a drainage field or soak away? Is it going to go to an adjacent stream, watercourse or drainage ditch? Is it going to go to a storm drain or mains connection? Okay, so you can't go to a storm drain anymore. I think since, I can't remember the year, maybe 2011 or such. You can go to a mains connection, obviously, if you've got one within a certain distance of your house. Drainage field or soak away, more problematic depending on your soil type. Okay, so can you use gravity to get the final effluent from the tank to the point of discharge? Okay, so this is basically, so the effluent comes into the tank, it runs downhill into the tank, and then can the effluent run further downhill out of the tank to your discharge area, wherever that may be? If it can't, it needs to be pumped, i.e. the effluent needs to be pumped out of the tank. If it can, that's fine, but you need to work out whether or not whether your levels are good enough that you can actually have a gravity tank, or whether, for example, if you want to discharge to an area that's higher than where your tank is, then it's going to have to be pumped. Okay, so that's giving you a rough understanding of what an engineer should be looking at when they come to your house. I mean, not all do, because some companies just send out a salesman who has absolutely no idea on anything. I mean, they'll talk a great game, but then that comes back to choosing a supplier. So check out our guide on that as well. Okay, cheers guys, thanks, bye.